TPF Software, founded in 1986, is a worldwide leader in developing tools for IBM's TPF operating system. Now, with the release of IBM's ZTPF operating system, we're pleased to introduce you to ZTPFGI, our comprehensive test management system for ZTPF. ZTPFGI provides an end-to-end solution for coding, testing, debugging, and analyzing ZTPF applications. The ZTPFGI Suite includes an integrated IDE so that one can edit, save, compile, build, and load to ZTPF using the same editor that the debugger uses. The suite also includes a Graphical Debugger. This is an end-to-end testing solution that makes it easy to load programs and to trace them at the macro instructional and source code levels. Our performance analyzer, ZTRex, is also included in the suite. This tool allows one to identify which applications are using resources by allowing one to capture and analyze resource utilization at different levels and by providing graphical representations to help one interpret the data. DF Explorer is a graphical interface that makes browsing and interacting with TPFDF easier. A resource manager manages the allocation and deallocation of resources. A regression test facility is also provided. This can be used to conduct regression tests on planned changes to ensure quality assurance. The ZTPFGI Connectivity Manager allows each user to be able to connect to remote resources without having to compete with other users. In the IDE, one can compile or build at the click of a button, and create a loader file with a single click. The IDE includes support for projects, and includes interfaces for browsing files on the host and PC, as well as one's library system. The ZTPFGI Library View can interface directly with one's own library system, allowing one to get, edit, and promote to source. Simply double-click a file from these browse views to download it and open it in the editor. Alternatively, one can even just drag a file and drop it into the editor to download and open it. Multiple files can be opened in the editor, each with its own tabbed page. The editor is the same environment that the debugger uses. The integrated IDE includes all the features that one would expect from a modern text editor. In addition, it includes features that help with writing code. It includes, amongst others, syntax highlighting, collapsible code, column guides, inline language help, find replace, and a files comparison tool. There is also a source outline for each file for easier navigation, and a tabbed output area that shows compile, build, or search results, errors, and other notifications. Simply double-click an error or search result to open the source file at the relevant line. The IDE even includes a Z Linux terminal. In ZTPFGI's Graphical Debugger, one can trace at the source code or macro instructional levels. It includes built-in terminal emulation for a number of terminal types, and one can even trace external resources. One can trace multiple programs via the editor tabs, set breakpoints simply by clicking in the editor's margin, and control the execution of the code with easy-to-use buttons for running, branching, etc. The debugger allows one to view and edit C, C++, and assembler variables via a clear interface that includes variable, watch, and call stack windows that are able to highlight changes to variable values to make them easy to use. The debugger includes a graphical ECB window that can show 64-bit information and clearly highlights changes to registers, data levels, and DECBs. One can perform macro actions such as swap C, flip C, get CC, or rel C via drag and drop. Multiple ECBs are supported via tabs. Each ECB's information is shown under its own tab. Simply double-click the graphical blocks to open core, file records, data levels, etc. for editing. One can even add DSEC panels to the block editor windows to make editing easier. One can even undo or redo edits where necessary. All this is provided within an intuitive, integrated interface. The ZTPFGI Performance Analyzer is called ZTRex, which stands for Transaction, Recording, and Examination. With this tool, one can analyze performance at the transaction, ECB, and program levels. ZTRex can provide data that shows memory, input-output, and program usage. It includes an intuitive interface that allows one to easily visualize and analyze the data. DF Explorer runs on real ZTPF. It is ZTPFGI's tool for interfacing with TPFDF via a graphical user interface. One can overlay the DF data with DSEC panels to make them easier to read, and one can browse, add, delete, or modify logical records of fixed or pool indexed files. ZRTF is ZTPFGI's integrated regression test facility. This is a test tool that can be used to ensure quality assurance. Results are displayed within the same editor that the IDE and debugger use. Like the rest of the ZTPFGI suite, ZRTF runs on real ZTPF. One can use ZRTF to measure the impact of planned changes on the ZTPF environment. It is customizable and runs with user-defined input files. It is able to log statistics from a wide range of events and can run in volume test mode or regression test mode. At a basic level, ZRTF measures the impact of proposed changes by comparing changes with the base run. First, ZRTF runs the test script and logs the output. Next, the planned changes are made to the test system and the test is run again. If one has two identical test systems, one can also run these two phases in parallel if required. Then, the pre-change run can be compared with the post-change run to measure the impact on the system. The Resource Manager manages the ZTPF resources. VPARS can be defined as private, shared, or on-demand. On-demand VPARS are automatically managed and are allocated as needed from a pool. The automation processes are user-configurable so that one can attach resources to a VPARS. The automation picks up the VP open parameters from the configuration file, which also contains the commands to be executed in the VPARS and how they are processed. The automation process is fast because it can bring up VPARS to a specified state for immediate use or for keeping in the pool ready for dispatch when needed. The process is as follows. A user, Client A, requests an on-demand VPARS. Client A's worker starts another worker, which brings up a VPARS, then disconnects so that Client A is connected to their VPARS. Next, the worker starts another worker. This time, the worker looks for an available VPARS in the pool, gets it ready for dispatch, then disconnects. Then, if a second user, Client B, requests an on-demand VPARS, their worker starts another worker that looks for an available VPARS in the pool. This time, a VPARS that is ready for dispatch is found, so this VPARS is given to Client B and that worker disconnects. Then, Client B's worker brings up another worker that gets another VPARS in the pool ready for dispatch, and the cycle is able to repeat. Connectivity management is provided by ZTPFGI's TPF to TPF function server, TTFS, which provides access to remote resources and allows resources to be shared. TTFS works by intercepting requests for remote resources and directing them through a server that has the actual remote links or connections. It's easy to miss the big picture when you work with pieces of a puzzle. The ZTPFGI Suite puts features and tools at your fingertips that help you to handle the big picture when developing for ZTPF. The ZTPFGI Suite is more than just a collection of parts. These parts work together to form a comprehensive test management system. This includes system resource management, a development environment, a graphical interface for debugging, connectivity management, regression testing, performance analysis, and a means to explore TPFDF. If one takes a closer look at the ZTPFGI kernel, this includes a centralized configuration management that keeps track of users and system resources, the APM server that manages the worker machines themselves, the debugger which runs on real ZTPF, not a simulator, the startup management that activates the VPARS, and the CPU management that ensures that the CPU is only used when transactions are running and puts VPARS to sleep when the system is idle. One can edit and compile their source files and load programs to ZTPF within the ZTPFGI IDE. The high-level process for this is as follows. One can access the source files on the Linux server and edit them as needed. This is provided via a secure FTP connection. One can then compile programs and create loader files on the Linux server via a secure shell connection. The loader files can then be uploaded to ZTPF for testing via an FTP connection. Once a program is loaded, one can connect to the VPARS when one's VM logon credentials are verified. Then, the APM server starts the product worker that validates security, connects one to the VPARS, acts as an intermediary between ZTPFGI and the VPARS, and handles data compression and logging. When the user disconnects, the worker and ZTPFGI close. ZTPFGI has a client-server architecture with 3 layers. The PC layer provides the graphical presentation to the user. The ZVM worker layer handles security and configuration as well as data compression and logging. It also puts the VPARS to sleep when transactions are not running. The ZTPF layer is where transactions are run so that they can be analyzed and debugged. Bringing the previous illustrations together, when one starts up ZTPFGI, one can browse, edit and save source files to the Linux server in the ZTPFGI editor via a secure FTP connection. One can compile, build and load files on the Linux server, and the Linux server can provide feedback for these actions via a secure shell connection. One can upload loader files to ZTPF via FTP. One can then connect to ZTPF to trace and debug the program. First, one's user ID is authenticated by the APM server. Upon success, a product worker for ZTPFGI is started, which acts as an intermediary between ZTPFGI and ZTPF. And a global usage logger logs the global usage data via an IUCV connection. The centralized configuration includes configurations that define users, resources, systems, and the on-demand VPARS automation. The configurations are mainly supplied by configuration files and user exits. The user configuration includes information about which resources the user has access to, the products the user has access to, terminal information for the user security level, and information about the user's files. The system configuration includes information about the system. This includes user limits, which products are authorized for the VPARS, information and preferences for handling files, and connection settings for the VPARS. The resource configuration contains information about the available resources, such as terminal addresses for built-in terminals. These are ALC, ALC printer, Local 3270, SNA, Customer Finance, and Linux. The resource configuration also includes information about any asynchronous user-defined terminals, as well as configuration settings of other resources. The automation configuration uses the system configuration to determine which VPARs are part of the pool. It defines the resources that each VPARS has access to and the commands to bring up the VPARS. It contains the configuration information for each resource that is available to the VPARS, and how to process and respond to the various commands that are necessary to run the on-demand VPARS facility. We've taken a brief overview of the ZTPFGI Suite. But what's the bottom line? Why should you decide to use ZTPFGI? Firstly, the configuration definitions mean that programmers do not have to worry about their access to resources. The integrated graphical interface means that the programmer doesn't have to learn to use different interfaces for different products, but can access the various tools via the same familiar environment. The ZTPFGI interface is intuitive, so it's easy to learn and easy to use. This all multiplies together to empower the programmer to optimize their workflow, which would result in increased productivity. Thanks for watching this overview of the ZTPFGI Suite. To find out more, please watch some of our other demos, take a look at our brochure, or contact us for further information.